connecting circuits. Okay, so now connecting pieces of gear, as I mentioned before, it's really important to get one signal efficiently transferred to the next piece. You're sending off to a reverb, you want the signal that's leaving here to get here most effectively and come back most effectively and not lose signal in the path. Just like in your computer, transferring data from one section to the next has to be done properly so you don't lose data. We need to be able to interconnect gear. Each piece of gear has an input and an output impedance, meaning that it's got a resistance to the signal coming in and going out, a resistance that happens to be frequency dependent. That's why when you get a piece of gear or a microphone from Guitar Center, you look in the back of the booklet that they give you, the technical booklet, and it has a whole chart telling you what the frequency response of the microphone is and so on, what the output impedance is, and all those details. Typically, most pieces of gear interface together very well. That's made to go together. Manufacturers know that their piece of gear may be used with a different piece of gear from another manufacturer, so they've kind of standardized it. You have to transfer a signal from one piece of gear to the next. So you've got an output signal and you've got an input signal, and they both have impedance. So the way to get the best signal transfer from one piece of gear to the next is the impedance relationship between the source and the load. The load is the input of the next piece of gear. The source is where it's coming from, the output. Output from equipment A, input to equipment B. And if you have an impedance that's 10 times greater on the input of piece of gear B, then you're going to get the best signal transfer from one to the next. That's not terribly important, except that happens to be the rule that output impedance should be 10 times less than the input impedance of the next piece of gear to get the most signal transferred. Now, it sounds really boring, like why do I need to know this? I just plug things together, it works. Well, when I was a kid, I got an electric guitar. I'm going to plug it in, but I didn't have an amp. So I figured a way to hook it into my dad's stereo. Well, I didn't know anything about input impedances or output impedances or levels or any of that stuff. I just plugged it in, and I plugged it into this auxiliary input, like where you'd put a tuner into his amp. And I played it, turned it all up, and it was like really quiet. I couldn't get any level out of it. It was buzzy, and it didn't sound good, and it wasn't working great. Then I looked on the back of the amp, and they had phono in. Let's try that. Because I didn't know where I was going with this. I just hooked up an adapter and was able to do it. And so plugged my electric guitar into the phono in. It just so happens the phono in is for a magnetic cartridge, which is very similar to my electric guitar. So it was built pretty much to adapt to the electric guitar. And of course, I didn't bother turning the level down because the auxiliary was not built to take an electric guitar in and transfer the signal properly, but the phono in was. So when I plugged it into phono and then I hit it and everything was on 10, I blew up the speakers. It sounded great for a second. Thought I was Hendrix for a second. And then the speakers blew up and I got in trouble. But certain inputs are better adapted to receive signals from certain pieces of gear and transfer the signal properly. When I plugged into the auxiliary, it was diminishing the signal that I was giving it and not giving me enough amplification. So I had to turn it up really loud and got extra noise in the signal. When I'd send it to the phono in, it was adapted properly and I didn't get extra noise, and it was loud and it was present and it was right. Unfortunately, I forgot to turn down the volume. That tells you that when you plug things correctly from piece to piece, it will transfer the signal more properly. The rule is that the output impedance should be 10 times less than the input impedance of the next piece of gear you're going to transfer the signal most efficiently. Now let's talk about the different signals. As we mentioned, microphones are real quiet, so they have to go through a special microphone mic pre to get up to the normal operating level. Electric guitars, very, very quiet in general, and a different impedance than your microphone. So a lot of times you'll go through what's called a direct box, which is a transformer box, to adapt it so that it can be going into a microphone mic pre so that it will be able to be amplified properly. So real quiet signals are electric guitars, electric basses, microphones. They're very quiet. The next loudest signal coming out of a piece of gear would be a synthesizer. Synthesizers generally between microphone level and line level, somewhere in the middle there. Depending on the manufacturer, they all have their own issues. So what do you do with a synthesizer? Do you plug it into a line input or into a microphone input? Many times you plug it into a microphone input, but then it's so loud going into the microphone input it can distort the mic input. So you insert what's called a pad to bring it down to lower level so it's more adapted to the microphone input, and then you can bring it back up to line level and get it standard for the rest of the studio. Or you could go into a line level and bring it up a little bit more so it's at normal line level, depending on if you have the control in your board to do that. And loud levels are normal line levels would be coming out of EQs, reverbs, compressors, pieces of outboard gear, tape machines, input and output are all line level standard. Boards like real boards with faders and such, that's all line level, period. Play live or you're playing a gig out or whatever and you play guitar, you play keyboard, you play any electric instrument, you sort of have a feel for how to make that sound right. Maybe you're mismatching it, but if you're not mismatching it, you're going to get the best sound out of your instrument. If you're mismatching it and you're plugging your synthesizer into a guitar amp, which is built to handle guitar signals, we know guitar signals are quieter than keyboard signals, you're going to generally overdrive your keyboard and make it distorted. High Z means high impedance. Low Z is low impedance. Z stands for impedance. Guitar is high impedance. Microphones can come in high impedance and low impedance. The best ones, like an SM57, is low impedance. So you'd go into a mic pre is low impedance input, the 3-pin, whereas a high Z in is usually a 1/4 inch. Bass guitar is high impedance. Any magnetic pickup is high impedance. Let's say you have a bass and you plug it into your direct box 1/4 inch in and a microphone cable out, then it can go into a microphone mic pre because the direct box adapts your bass from high impedance to low impedance and your microphone input is a low impedance input. If your board has a high Z in, meaning high impedance in, then you don't have to go through a direct box at all. You can just go straight in. In fact, I have an API mic pre, which is a specialized mic preamp, which is high end. It takes my microphones in the back and turns them into line level, but in the front it has a 1/4 inch jack that says high Z in, and when I want to record bass, I just plug it straight into that, and it adapts it and is conforming to the different impedances. Okay, so the transfer of signal from a microphone to the mixer to the power amp to the loudspeaker, all done with cables. And I gave you a little slide here to examine that shows the output impedance and the input impedance of the next piece of gear being 10 times greater. And these are typical, actually, of what real pieces of gear are like.